Okay, so Brian, your team showed that space started off expanding slowly, but it's actually been accelerating. The expansion has been getting faster and faster.
Yeah, it's a crazy result. It seems to mean things are working completely counterintuitively.
So what could be causing this?
Well, we really need to have something like gravity pushing rather than pulling. And doesn't seem, we always think of gravity pulling all around us. So this is a bit of a surprise. But it turns out Albert Einstein, back in 1917, figured out a way to make gravity push rather than pull. And it was by there really just being energy everywhere that was part of space itself. And so when space gets a little bigger, it turns out this stuff gets created as space gets a little bigger. And that gives it a bizarre property, a property which we call negative pressure. Now, I think everyone knows what pressure is. Pressure is that when I push on something, it pushes back, right? But this stuff has negative pressure. When I push on it, it wants to shrink. When I pull on it, it wants to pull even farther. So it sort of does exactly the opposite what everything else should do.
But that's presumably only one possibility. This idea of Einstein, what we call the lambda, is one way to do it. But presumably any force that is stronger than gravity and pushes, gravity can only ever slow things down. So if you want this expansion, we have to have a force that's opposite to gravity, that pushes rather than pulling, and it has to be stronger than gravity. And any force that does that could do the trick. Lambda Einstein's theory is one possibility, but I believe there are several thousand other possibilities. The trouble would have to be this force would have to be long range. Gravity is strongest when things are close together, but if you had a force that's stronger than gravity but repels and also is strongest when things are close together, it would blow the Earth apart. It would fling us off the floor of this room. So it's a bit weird. We need a force that's long range and pushes rather than pulling.
Right, and so Einstein's version really does sort of do this with gravity because it's spread everywhere, so that sort of makes it very long range. There's no extra of it anywhere. But it has this property of as I said, this negative pressure, which is genuinely counterintuitive. But there's, as you said, thousands upon thousands of theories that have been developed. A lot of them are a lot like Einstein's. They make this negative pressure stuff fill the universe in all sorts of ways. But then people have the universe being sort of lumpy or having new forces or all sorts of things. So, the only way we're going to know this is by testing.
But let me ask a personal question. Your team was responsible for discovering this repulsive force that we now have taken to calling dark energy. Are you really sure it's actually there?
Well, I have to admit, in 1998, when we made the discovery, I knew what our data said. I knew the data said that the universe was speeding up, but I had my doubts because it was just a crazy thing for the universe to be doing. I figured maybe some other explanation would come along. I felt pretty much our observations were right, but you have to interpret your observations. But now, in the current time, we've had many, many experiments. Not only do they see the same thing that we see, so okay, that tells us our observation's right, but they've looked at it many, many different ways. And so the interpretation, the idea that the universe is speeding up, has many manifestations of how it affects the universe. And every time we look at the universe, how fast galaxies form, how sound waves travel through the early universe, you keep on getting the same crazy answer that the universe is full of something that is speeding it up. So at this point, I think that's a good sound way of describing the universe. So I'm pretty confident it's going to stand the test of time at this point.
And presumably this whole idea that the universe is accelerating, that there's something, dark energy, whatever it might be, one of these 10,000 theories that's making it go faster, that must have incredible implications for the future of the universe.
Well, it does, because, the big question that I had when I started this work back in 1994 was, does the universe, exist forever, or does it eventually collapse and go into the Big Bang backwards, the Gnab Gib? But this gives us an answer, tells us the universe is going to last forever, but with a twist. The more the universe expands, the faster it expands. So it accelerates. So imagine that I'm looking at a galaxy on the other side of the universe that I can see right now. Well, in the future, because space is being created so quickly, the scale factor is being, increased so quickly, light is going to get stranded as the scale factor, stretches the universe faster and faster. And so things we can see right now will not be visible in the distant future. They will sort of get frozen in time and fade away. So if I had a galaxy on the other side of the universe, its clock would stop, it would fade away. So for future generations of scientists, 100 billion years in the future, they're going to look out and they're going to see no galaxies. All the galaxies we see today will be so far away, there'll be nothing left to see. And that, I find profoundly disturbing. Why would we live in a place where we can see the universe, not in the future when it will be nothing to see?